Hello everyone, Assalamu alaikum warahmatullah. Today's lecture is about alcohol, and very shortly I shall explain about alcohol naming and some process of preparations. Before going to explaining the preparations, we need to know that what is the definition of alcohol and how we can name it. Simply, if we see that aliphatic hydrocarbons, in case of aliphatic hydrocarbon, this is carbon and the other side is all about hydrogen. If one hydrogen is substituted by a hydroxyl radical, OH, then it is actually alcohol. So we know that actually the based of a number of carbon, I explained it several times, and you know that based on that number of carbon we say meth, eth, prop, butane, pent. So here we need to think about that how many carbons are there in case of naming of alcohol. But the definition is that in saturated hydrocarbons or aliphatic hydrocarbon, if one hydrogen, at least one hydrogen is substituted by one hydroxyl radical, then this is alcohol. Well, and now if you just focus about naming, in case of naming, what to do? In case of naming, you see that first there is alkane, and then this E would be omitted, so E would be gone, and then with that all would be added, so that is called alkanol. Now you think that here a single carbon, so accordingly we can say this is CH3OH, that is methanol, because carbon 1 is meth. So this is methanol. We can say methanol. After that, if you see if there is two carbon, that is CH3 bond CH2 bond OH. Now you see there is two carbon, and we can say this is ethanol. When there is three carbon, CH3 bond CH2 bond CH2 OH, now we can think that there are 1, 2, 3 carbon, so the name is propanol. Simple. So alcohol naming is very simple. Now if there is a branch, then what will happen? If there is a branch, then what will happen? Think about that. Methanol, ethanol, propanol, butanol, pentanol, hexanol, heptanol, octanol, nonanol and decanol. That would be easier for you because this is very simple, understanding the number of carbon, and there is a presence of hydroxyl. So you can name it based on the number of carbon in that compounds. But if there is a branch, think about it. Carbon, 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 OH. Think about another carbon, and this is a methyl group. CH3 is attached. Now you think that, of course, I know that alkyl group. You know what is alkyl group? Alkyl group is that alkane, from alkane one hydrogen is lost. So CH4 is methane, and according to this, as CH3 is an alkyl group, this is methyl group. If there is CH2, CH3 are there, then this is ethyl group. Now one methyl group is added. What is the thing? That CH3, CH2, that should be CH, this is CH2 and OH. Now you think, I always say that we have to understand from which side we will count the number of carbon. Should we go from here, that 1, 2, 3, 4, or should we start from the right to left? What we need to know, in this case you must remember that we must count hydroxyl in the smaller number of carbon. So that is why it should be 1, 2, 3 and 4. So as this alcohol group, that is hydroxyl group, is in number 1, so methyl is a branch, it is actually in second carbon. with the second carbon. So we will name it. Previously, we know that according to UPEC system, we have to say first prefix and then word root and then after what? Suffix. So according to the rules, the prefix is here 2. So this should be 2-methyl. Okay, number of carbon 4. So we can say alkyl. So we say buta. You can differently say that butanol 1. 2-methyl butanol 1. That's because this is actually CH2OH is given as number 1 carbon, so we say 2-methyl butanol 1. If things like that, 1, 2, 3, 4, 5. Okay, here is CH3 and here is CH2CH3. If this is the situation, I'm just not giving you some sort of like a difficult thing, but it's easy to understand the naming process of every organic compounds like alkane, alkene, aldehyde, fatty acid and all other things, but this is alcohol. Now you think, if the hydroxyl group is here, suppose CH2OH, okay, here CH2, CH, this is CH2, what would be the name of these compounds? Now don't think that this is ethyl. No, do not think that this is ethyl. We need to count the maximum longer chain in that compounds. Now you see, we said that hydroxyl should be at the minimum number of carbons. So it should be 1, 2, 3, 4, 5, and this is not the branch. So we can go for next 6, 7. So according to this is the longest chain. And here in number 3 there is a branch, and here there is a functional group, that is hydroxyl. And from that we know this is alcohol. But to name it, we need to think first the longest carbon chain. Which is the longest carbon chain, and when, from which side we should count it. So 1, 2, 3, 4, 5, 6, 7. Accordingly, this is heptane or hepta, that is 7 carbon alcohol, and the methyl group is in number 3 carbon. So we can say this is 3-methyl heptanol 1. 3-methyl heptanol 1. So this is simply when in case of hydroxyl, in case of branch presence, if there is CH2, CH3 are there, suppose here CH2, CH3, then what would be the name? That would be the 3-ethyl heptanol 1. As because this is CH2CH3, that is ethyl group. We know that ethane is C2H6, so bond C2H5 is ethyl group. So we know, because organic chemistry is just like a novel. So you are reading a novel from the first page, and then you are understanding the character of the things and the insight of the story, and then now based on that previous knowledge you are going through. So I hope you have already seen my videos based on the alkane, alkene, alkynes naming, and this about alcohol, and then after I'll definitely explain about ketone, ether and fatty acid. So in this case alcohol is based on the branch. So I hope you understand till now. Now one thing is important. If there is more than one hydroxyl group, suppose CH2, CH2, okay, here one hydroxyl and another hydroxyl. If two hydroxyl is present in a single compound, then this is called polyhydroxy alcohol. Well, the name would be 1, 2 ethane, ethane diol. In this case, if there is 2 hydroxyl, name would be diol. If there is 3 hydroxyl is present, then name would be triol. 4 hydroxyl also can present. This is called tetraol. So this diol, triol and tetraol would be naming based on the number of hydroxyl. If there is more than 1 hydroxyl, then this is called what? This is called even you can say in case of polyhydric alcohol. I'm just coming up next that what is the classification of alcohol naming based on the number of hydroxyl. If there is more than 1, suppose CH2, CH2. If there is hydroxyl and hydroxyl. Now you see there are 3 hydroxyl present in this compound, so this is triol. But the chemical name of this compound is glycerin. You can say this is glycerin, which is the production of when we will study about soapinification. No? The production of soap preparation, so that glycerin would be another product. So CH2, CH2, there are 3 hydroxyl. So if there is more than 1 hydroxyl present in an alcohol compounds, then this is polyhydric alcohol. So now let's study a little bit about alcohol types and classification. What about the alcohol types and based on the hydroxyl group? So I hope you know this is methane, ethane, propane, butane. I hope you know it. So now you can think about the classification of alcohol. What is the classification? 2 types. Very simple. So simply we can say that number 1, that is monohydric alcohol, and in other case we can say this is polyhydric alcohol. Very simply, this is single hydroxyl, 1 hydroxyl present and 1 hydroxyl present, but here we can say more than 1 hydroxyl, 2 or 3 hydroxyl, whatever I can say. Polyhydric means a lot. Poly means lot. That we see that polymerization reaction. So more molecules will added. This is polymerization. So poly means more than 1. So monohydric means 1 or single hydroxyl is present. But interesting factor is it is again 3 types. We'll have 3 types. Number 1 degree alcohol, 2 degree alcohol and 3 degree alcohol. Or you can say the primary alcohol, you can say secondary alcohol, and this is tertiary alcohol. How we can actually memorize it? It's not about memorizing. We definitely a lot of practice needed, but we can see it and we can find that either it is 1 degree, 2 degree or 3 degree alcohol, but all are monohydric alcohol. How come? You see that in case of alcohol, ROH is the very simplest expression of the functional group of alcohol. It means that with this carbon, 1 hydroxyl would be there, and other side there would be something, and that something, it can be hydrogen, it can be hydrogen. Okay, so if it is hydrogen, this is very simply methanol, that is CH3OH. But if this is a longer chain, suppose R, if there is longer chain, then this is 1 degree or primary alcohol. In primary alcohol, at least there will be CH2OH, so this is R, and a single alkyl with the presence of CH2OH group, it means this is 1 degree or primary alcohol. But if this hydrogen is again substituted by another alkyl, then this is secondary. So it would be CHOH, and CHOH will be there. It was CH to OH, but here 2 alkyl group is attached. This is called secondary. In case of tertiary, this hydrogen will also be substituted by another alkyl group, and then it would be COH. So only carbon would present, and then the other side alkyl group will be substituted. So there is no hydrogen present in case of tertiary or 3-degree monohydric alcohol, because all hydrogen is already substituted by alkyl group. So minimum group is, in case of tertiary, is COH, in case of secondary CHOH, in case of primary CH2OH. So I hope you understand. And in polyhydric alcohol there is more than one hydroxyl. As you see that in case of previous CH2OH, so 1, 2 ethane diol, triol, tetraol, these all because of the number of hydroxyl is more than 1. Okay, so let's practice something. In this case, I hope you can remember what is monohydric and what is polyhydric. Think about it. Suppose CH2OH are there. Okay, so with that, this is CH2OH, which is monohydric 1-degree alcohol. So I can write it here that 1 degree is CH2OH, but there is what? There is 1 alkyl group. In case of 2 degree, there would be CH, but 2 alkyl group OH, and in case of 3 degree, there would be 1, 2, 3 alkyl group, and simply there would be hydroxyl. So I hope you can remember this very simple formula to memorize, which is 1 degree, 2 degree and 3 degree alcohol. Also you can say primary, secondary and tertiary alcohol. So here is CH2, CH3. So simply I can see that CH2OH is present. So simply this is 1 degree alcohol. As this is 1, 2 and 3, we can say propanol 1. Propanol 1. This 1 degree. So simply we can go for CH3, CH2, whatever you can go, CH2. Even if there is any branch, whatever, CH2OH, CH2. So 1, 2, 3, 4, 5. There is 5 carbon present, and CH2OH is present also. So from the last part we see this is 1 degree alcohol and there are 5 carbons. So this would be pentanol 1. Okay, in another case, CHOH, there would be CH3 and there would be CH3. Now you think, what is the name of this compound? The interesting thing is that now the chain is like vertical. So you name it like 1, 2 and 3. And you see that in second carbon there is an hydroxyl group. So the name of this compound would be 1, 2, 3 propanol 2, as this hydroxyl is in second number carbon. So that the name would be propanol 2. Now you think that CHOH. So there is CH2, CH3 and this is CH3. What would be the name of it? And why, what is the maximum number of carbon we can get? Like 1, 2, 3, 4 or 1, 2, 3, 4. In which way we should go? We should go the way that we must find the hydroxyl group is in the smallest number of carbon. So we should start from here 1, 2, 3 and 4, and the longest chain is here like this, and then this hydroxyl group is in second number of carbon. So the name of this compound is 1, 2, 3, 4, that is butanol, and we can say this is butanol 2. In other case, if you see that CHOH, okay, very good, that is CH2, CH3, that is CH2, CH3. Now you see what would be the name of this carbon compounds. So from anywhere you start, this carbon or the hydroxyl would be in the same carbon. How? Because if you start from left to right, then 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. From anywhere we start, the hydroxyl is in third number carbon. So the name of this compound is pentanol 3. Okay? So as this is two alkyl groups together, then this is what? 2-degree alcohol. In other case, 3-degree alcohol. Okay, I hope you understand. In other case, 3-degree alcohol, if you need to understand what is 3-degree alcohol, now you see the smallest one, OH, this carbon is attached with that, here CH3, here CH3. Now you think, there is nothing, I mean with carbon there is no hydrogen, so COH is there, and definitely we understand this is tertiary alcohol or 3-degree monohydric alcohol. Now you think, from which corner we should start? Well, if we go for like that, 1, 2, 3, okay, 1, 2, 3, also okay, 1, 2, 3, okay, but it doesn't fact like from which corner I can go, but 1, 2, 3, if I count it, then we can see that with these two position of carbon, there is methyl group and hydroxyl, and 1, 2, 3, that is propane. So we can say the name of this compound is 2-methyl propanol 2, or we can say 2-methyl propane 2-ol, propane 2-ol. Also you can say that, because propane comes from the word root. 2-methyl is the prefix and 2-ol is the suffix. According to the 1993 UPEC system, we are naming it. So 1, 2, 3, whatever. Now you think simply that in these compounds only hydroxyl is present. Hydroxyl. So this hydroxyl, you see, hydroxyl CH2, CH3, CH2, CH3 and CH3, whatever. Now what is the longest chain? From where we should start? If you start from here, 1, 2, 3, 4, 5, that is 5. 1, 2, 3, 4, no. 1, 2, 3, 4, 5, also okay. But this carbon is always in number 3 position. So if we start from here, 1, 2, 3, 4, 5, we can consider that this is definitely penta, that is 5 carbon. And in 3 number carbons, there is hydroxyl and methyl. So we can write this is 3-methyl pentan 3-ol or 3-methyl pentanol 3. So we can say this is 3-methyl pentan 3-ol or 3-methyl pentanol 3. So I hope you understand the process or the types or classification of alcohol. So in this video I tried a little, simple way from my side to explain the types of alcohol based on the number of hydroxyl. So you can name it as 1 degree, 2 degree, 3 degree alcohol. When you can see that there is CH2OH present, that is 1 degree. CHOH present, 2 degree. COH, I mean hydroxyl and carbon is, they're single, that is called 3 degree or tertiary alcohol. And previously I said that if there are more than one hydroxyl is present, you can name it as a polyhydric alcohol. So in these sections I hope I can move into the next part, and the next part is very important, the preparation of alcohol. Let's study about the preparation of alcohol, the second part of this lecture. Preparation of what? Alcohol. So students, those are watching right now, I hope you know that organic chemistry is a very interesting thing, and from first to last, if you put your 100% effort, then definitely it will make you happy when you study organic chemistry. Otherwise, it doesn't give you some sort of soothing and peace inside. So as you are studying, I'm requesting you all, think. Number one, preparation of alcohol. Number one is hydrolysis of alkyl halide. What does it mean? Or haloalkane. Haloalkane. What does it mean? So hydrolysis of haloalkane. So we can produce alcohol from the hydrolysis of haloalkane. How? Suppose this is RX, alkyl halide, is reacting with sodium hydroxide aqueous solution. Mind it, this is aqueous solution and temperature would be there. So this X and sodium, and then what will happen? ROH and sodium halide will be produced. Very simple. I hope you can see this. And in this case, soda, that means sodium hydroxide or caustic soda. Think about it. CH3, CH2, iodide, ethyl iodide. You know ethyl iodide is reacting with, not 2 actually, it should be sodium hydroxide, simply sodium hydroxide, but that is aqueous solution and there will be heat. What would be the reactions? Sodium would be iodide and hydroxide will come here. So that would be CH3 CH2OH, which is ethanol. So that was ethyl chloride, and this is ethanol. So you understand that ethanol is producing, and simply sodium halide would be the next product. So sodium halide, that is NaI, will be produced. So we can find alcohol from alkyl halide with the reactions of sodium hydroxide. Sodium hydroxide, aqueous solutions. If we heat alkyl halide, then corresponding alcohol will be produced. Corresponding alcohol means if you take the alkyl from 2 carbons, that would be a 2 carbon alcohol. If there is 4 carbon alkyl halide, there would be butanol. If there is 5 carbon alkyl halide, pentanol. Okay? Okay. So first process is what? Hydrolysis of haloalkane. Okay? I'm removing it. Second thing is that we also can produce alcohol from alkene. Okay. So second is from alkene. How come? We can see that CH2 double bond CH2 is reacting with sulfuric acid concentrated in 100 degrees Celsius. Then what will happen? According to the Markovnikov, that is the next part, but I'm just giving you a simple idea that H2SO4 is like H plus HSO4 minus. So simply there would be CH3 CH2 HSO4, that is ethyl bisulfate, or you can say ethyl hydrogen sulfate. And then after this ethyl hydrogen sulfate would be hydrolysis, taking part of hydrolysis, and then HOH, so it will produce CH3 CH2OH plus H2SO4 like before. So this is the very common process. In your exam, I hope you know that if you see the test paper or previous questions, a lot of important questions came from this organic chemistry series. There will be some sort of like transformations from alkane to fatty acid, from alkene to fatty acid, from here to here. So we can roaming around from here to here. So on that level, if you want to study on that level, this one is important. So first we think we can go from alkene to alcohol with the presence of concentrated solutions of sulfuric acid. So in first cases, sulfuric acid will produce ethyl bisulfate or alkyl bisulfate, and then hydrolysis will take place, and then alcohol will be produced. So always remember the number of carbon. If there is propene, there would be propanol. If there is butene, there would be butanol. But from alkene to alcohol, we must add sulfuric acid, but concentrate level. Okay, now the second part is done. Third part is that we also can produce fatty acid from carbonyl group. Carbonyl group. So number 3 is from carbonyl group. What does it mean? We can also produce from fatty acid from aldehyde, suppose CHO. We also can produce fatty acid from ketone, and also carboxylic acid. Very simple. Why this is carbonyl group? You see the structure of aldehyde, that is C double bond OH. So there is the presence of carbonyl, means C double bond O would present. And in this case, this is very simple, is given like that, CO, and here C double OH. So this is actually like this. So you can see every time there is a presence of C double bond O, C double bond O, and C double bond O. So you also can produce alcohol from these. How? Simply we can say that in case of aldehyde, think about it. Suppose this is A, CH3, CHO. This is aldehyde. So with this aldehyde, it would be reduced by 2 nascent hydrogen with the presence of hydrogen or platinum. Now you see what will happen. 2 hydrogen will added here. So that would be CH3 CH2OH. CH3 CH2OH. That is ethanol. Ethanol. So that is ethanol or ethyl aldehyde. So ethyl aldehyde, and this is ethanol. Very simply, when aldehyde will be reduced by hydrogen or nascent hydrogen, then alcohol will be produced. Think about ketone. Ketone, CH3COCH3. Okay, ketone. And then if you again hydrolysis by nascent hydrogen reduced with the presence of lithium aluminium hydride. Lithium aluminium hydride with ethoxyethane. And then what will happen? There will be, you see, CH3 the functional group in between. So it would be like CHOH CH3, and simply this is CHOH, 2 degree alcohol. So from aldehyde 1 degree alcohol is being produced, 1 degree alcohol is produced, but from ketone 2 degree alcohol will be produced, 2 degree alcohol will be produced, and this is propanol 2, propanol 2. So the name is propanol 2. Now in third case, from CH3 COOH, COOH, again the process is that 4 nascent hydrogen and lithium aluminium hydride with solutions of ethoxyethane will produce what? Now you see, CH3 CH2OH, and again this is ethanol, and CH3 CH2OH, with that water will be produced. So now you think simply, from carbonyl group we can produce alcohol, from aldehyde, every time when carbonyl group will be reduced by hydrogen, then alcohol will be produced. So I have already explained 3 types of alcohol preparations. Number 1, that alkyl halide is added with sodium hydroxide, aqueous solutions, then from alkene to alcohol, and then from carbonyl group to alcohol. So you also can produce alcohol from aldehyde, ketone and fatty acid. So I will definitely explain a lot of transformations from here and there after, but before I'm just giving you a serial explanations from my best end, and I hope you will practice, and if you can practice, I think things will be much more easier for you. So take this thing, and if you don't understand any part of any lecture, then please let me know in the comment sections, and definitely I will answer appropriately. So thank you so very much. In next tutorial I'm coming up with fatty acid, aldehyde and ketone naming and preparations. Okay, take care.